Yeah, so hello, folks. Thanks for attending, and thanks to Gigians for this wonderful opportunity to talk about such an impactful technology that is emerging and changing the landscape of how we develop software and how privacy is treated. So let's talk about the Web3 stack. I think I should thank Saurabh, the previous speaker, who presented a great premise for my current topic because he did explain a lot of things that I'm about to present, which will lay a foundation to how you can build better DApps. And I'm going to be talking about the stack, which is basically the tech stack which you would otherwise use in the current Web2 technology, and how it translates into the Web3 world. Uh, so let's take a look into how the Web2 stack is currently. I think the most basic things that we would often require are things like authentication, database, cloud storage, and some more security layers, load balancing, cache, server. Although these might be quite efficient in delivering data and fast, obviously the biggest concern over the past few years have been data privacy and all the ways that these big tech companies are storing data, and which the user doesn't even own, and it is in the hands of big corporations. So that is a major problem that Web3 is trying to solve. But apart from that, Web3 is also trying to solve a lot of things like incentivization, and there's also a lot of other technologies apart from DeFi and NFT metaverses, like supply chain management and regenerative economy. So all these require a lot of things in the Web2 world, which probably wouldn't have been possible a few years ago when Ethereum was found, because Ethereum was great. Like, it was a new foundation to the entire stack, but all it could do was validate transactions, and it couldn't provide any efficient data uh, to the front end through which you could display a lot of things, like display a lot of things very quickly, which today's technologies like AWS or Google Cloud can do. So that is where a lot of these protocols in the tech stack come into picture and help build better apps. So let's talk about from the ground up of how you can build your first DApp and which technologies or tools might be relevant for you or the protocol that you are building. And these might some of these might be really useful and very use case specific. But I'm going to try to cover the most general topics that will help you build your next DApp in any space like DeFi, Metaverse, or any other use case you have. So I think as the previous talks mentioned about the basis of blockchain and how blockchain networks work, I think the biggest one, how blockchain was formed, was the layer one blockchain, where this is the base layer where all the transactions happen, all the ledger is made, and that based on a consensus mechanism such as proof of work or proof of stake. So I think a lot of evolution has happened over the past few years. Of course, Ethereum being the first one, but we knew how slow it was and the limitations of Ethereum. So a lot of blockchain networks have been built around it to better improve the vision that Ethereum laid out. I think the biggest names are Solana, the Near protocol, Celo, Tezos. So they have unique features by themselves. Solana, for example, uses proof of time to validate transactions, which makes it very faster than Ethereum. It can almost validate 50,000 transactions per second. And Celo, on the other hand, has a unique feature of being able to pay the gas fees in stable coins, which I believe no other blockchain has. And Tezos is self-amending, meaning that it has a governance protocol which lets it self-amend without having to do a hard fork of the network. So this allows for easy upgradation of nodes. So all this play out a very large role in building more and more better DApps, which are very specific to the use case, and that's where they have built a great ecosystem around themselves. And there is no one winner, I guess, because all of them have limitations and all of them have different features. But obviously, there are some limitations to all these layer one blockchains, which is popularly known as the blockchain trilemma, which simply says that you can have either any two of these, scalability or decentralization or security, but not all of them. Of course, some blockchains like Solana are trying to solve it, but there are also layer two solutions which try to initially solve it. Basically, Polygon is I think the leader in this space currently, trying to which has more than 700 DApps deployed on it, and it's gaining momentum and traction each day. Well, there are also other technologies like zk sync and optimism, which basically use zero knowledge proof to validate the transactions. So how these layer 2 chains work is that they validate all the transactions for very low gas fee and increase the transaction rate, while acting as the commit chain, where they finally commit all of those transactions to the main Ethereum chain or any other chain. Then there are also layer zero chains. So obviously the biggest problem with layer one or layer two chains is interoperability. That's why layer zero chains allow uh, blockchain networks to be built on top of them using their SDKs. I think Cosmos is a very popular one where Binance Smart Chain was built on top of it. And there's also Polkadot, which utilizes concepts such as parachain, which can talk to where different blockchains can talk to each other. So these are definitely more revolutionizing the concept of interoperability and multi-chain concept. And then we also have uh, decentralized storage. So obviously not all data can be stored on chain, and it doesn't even make sense because some networks also have high transaction fees and high cost fees based on what data is stored. So blockchain networks, the gas fee you pay while deploying a program is basically the amount of storage that the program takes up or the computation that the program requires. So storing big files would obviously not be very optimal, and that's why we have decentralized storage networks. So I think IPFS is the biggest name here. It is basically interplanetary file system, uh, which is based on the fact that if you were suppose on another planet and you wanted to fetch a network from Earth, it would take you more than 8 minutes. But if it was cached at different nodes in different planets, then it would be very easily accessible because it's decentralized and that website is available anywhere rather than on a single endpoint on Earth. And Filecoin adds an incentive layer to this, making it easy to store NFT metadata and all kind of other game assets. I think Filecoin will be especially useful in building metaverse apps where you have to store a lot of metadata of game assets and all these other kind of large object files. And yeah, so next we also have indexing protocols. I think like the previous speaker mentioned, like indexing protocols are becoming more and more helpful and popular because obviously the transaction data that you get from Ethereum or any other blockchain is very limited in speed because uh, the transaction has to go through the network request basically has to go through every request, every transaction in the blockchain and get the data pull from every history that has been created. But what indexing protocols allow you to do is index that blockchain data and then easily deliver it to the front end. This way you can build efficient front end apps using common technologies or common patterns such as pagination or getting only the data you want. I think the popular one is the graph, which basically lets you index different contracts, and it allows you to query in GraphQL. And there's also other examples such as Covalent and Morales. In fact, Morales does a lot more than just indexing. It has authentication APIs which easily let you connect with a wallet and handle all of the user data and fetch the NFTs of which the user owns. And it also has cloud function triggers where you can perform a specific action in the Web2 world based on what happens in your contract. So these are obviously a lot of amazing technologies that are required to build a fully functional, efficient app. Using like only blockchain layers would not be possible. And then we also have cross-chain bridge protocols. So I think the biggest problem also with the current blockchain networks is there are so many of them, and sometimes you might want to transfer your assets from one of the chain to another, and that is technically impossible, like because no chains can communicate with each other. But this is where cross-chain bridge protocols come in, and what they do is they let you transfer native assets from one token to another. If suppose I wanted to transfer my Ethereum on the Polygon network, obviously there are two different chains and they can't easily talk to each other, and especially can't uh, transfer the native tokens. So what I would instead do is go to something like Stellar Network, which is the I think the biggest name in the cross bridging. So what Stellar Network does is I will tell Stellar Network that I want Ethereum on my Polygon wallet address, and Stellar Network will simply take my Ethereum, wrap it uh, in the sense that they will take my Ethereum and they will give me Polygon on my Polygon address, but they will give me Ethereum on the Polygon address, but they will give it as a representation of of the Ethereum native asset Ether. So they give a wrapped Ether instead of the native asset Ether, and this is how cross chain bridging protocols help you simulate the effect of native tokens on other chains. So you can have wrapped Polygon Matic, you can have wrapped Ethereum and wrapped BNB. So all these represent actual value of the token, but not the actual native asset from the other chain. I think the biggest examples here are Seller Optics, which is on Celo, and Wormhole, which is on Solana, and all these three help interoperability between Solana, Celo, and Ethereum, and all the other big chains. And then we have Oracle service. Another great disadvantage of blockchain is a blockchain can only read and write data within its ecosystem or within its contain. It's like a container basically, and it can't really look outside of it. This is where Oracle services come into play. Oracles are basically something like a magic where you can pull data from outside the blockchain and help blockchain understand like manipulate that data. And I think Chainlink is one of the biggest examples here, helping building an incentivized layer to perform Oracle actions. So Chainlink has been used by multiple protocols and dApps. I think the biggest example is of liquidity providers. So since liquidity providers are like liquidity pools are deployed on blockchain networks, they don't really have a sense of the actual market value of that particular token. So this is where Chainlink can go to a market like CoinMarketCap, get that data, pull in the data and the market volume and all these essential data, and then the smart contract can figure out what should be the price swap between them. And this is how they do it. So that's why Chainlink is really really essential for if you want to build anything that is connected to the real world data, such as temperature or famines or anything that can happen that will affect the app. And then we have DeFi protocols. So you might obviously have a lot of use cases and dApps where you would want to integrate uh, some kind of DeFi feature. Suppose you want to build an insurance dApp which will provide some lending protocol. Obviously, you don't have to reinvent the wheel of making another new lending protocol. You can just simply use APIs provided by companies like Uniswap, Aave, and Superfluid. So all these have different specific use cases. Uniswap helps you provide a liquidity pool, create your own token with a pair, which can then provide value to it. And Superfluid also helps in streaming money, which was explained earlier, I believe. So, for an example, if you had a loan, or if you are suppose watching a YouTube video or a Netflix video, I think the biggest way that Superfluid would help is obviously you pay for the entire month subscription of Netflix, but a great value addition would be that you pay for only what you watch. Like suppose if I watch for 10 minutes, I believe that I should only pay for that. And Superfluid helps you accomplish that by streaming money for only that amount of time. So this is how you can integrate many of these DeFi protocols into your dApps for helping you stream money and provide liquidity and swapping. And then we have node services. So this might be if your dApp scales a lot, if you have a ton of users, I think having a private node or having a node provider for your app specifically might be a requirement, because what happens on Ethereum nodes or what happens in nodes on a blockchain network is that they get congested, and if there is a large transaction volume, they often get congested, and the transactions become very very slow. So if you want to have a great user experience for your user without having a lot of delay times in the blockchain networks, especially if the blockchain is slow, like Ethereum, then you might want to consider like a node provider. So node provider just hosts that particular node, and they provide a private API so that only your transactions go through to the node, and there is no network. There's enough bandwidth available for your DApp. Uh, this way, node providers help you communicate, like build a DApp for while having an efficient node, so that way that your DApp doesn't hang or it doesn't get slowed down. So some great examples here are obviously Infura, I think, is one of the big names, which helps you provide custom node RPC endpoints. And then there's also Quick Node and Figment. They're also picking up speed and sponsoring a lot of hackathons where you can host your private nodes. And then there's also Alchemy, which node providing is also one of the services of Alchemy. And I think the biggest thing after all of these protocols is actually the developer experience, because ultimately you're the one who's coding on top of all of these APIs and all of these different protocols. So it is obviously important that you have a great tooling in place that helps you manage your project, that helps you test your project well, so that it doesn't have bugs, because having bugs in the Web3 world is unaffordable. It can create impermanent loss of money. So it is really important that you have a framework or you have some kind of testing tool that helps you manage it. So I think in the Node.js world we have npm, we have yarn, and similarly in the Web3 world we have a couple of ecosystem, uh, like Truffle. I think Truffle is one of the biggest names in managing projects, because it has a easy to use JavaScript API, and using which you can write test suits. It also gives you a private. It also gives you a test blockchain using which you have a couple of keys and couple of public keys which you can easily test your smart contract with. Then there's also Hard Hat, which is again a JavaScript implementation, and there's also Brownie, which is a Python implementation. So if there are any Python lovers who don't like JavaScript, you might as well use Brownie, as it has a very easy to use Python interface and CLI tooling. So all these help you create, update, create contracts, and manage the entire life cycle of your smart contract. So it is really essential to have one of these dev tools in your Web3 app. And then we also have wallet and identity. So I think this is one of the major changes that Web3 has gone through. That the authentication layer has been simplified to uh, a very single unique identity, which is probably your wallet address. So any DApp you build would probably require the user to log in using their wallet. I think MetaMask is obviously a well-known name here. So knowing MetaMask APIs is a great advantage of how you can use MetaMask, use it to sign transactions and interact with your protocol. And then we also have Wallet Connect. So Wallet Connect is slightly different, where it allows the users, especially on mobile phones, there is no way to easily interact with a wallet, because unlike a browser, because it's not an extension, it's a whole new app. So Wallet Connect provides a private server where your DApp can send requests to the the wallet, like in this case would be MetaMask. So my DApp can request MetaMask through Wallet Connect to make transactions or make any kind of requests. Then we also have Phantom and Trust Wallet. Phantom is from the Solana ecosystem, and Trust Wallet supports multiple networks. So that's where it's really unique. And so finally we have developer resources. So obviously this all of this may seem overwhelming, and there are a ton of protocols which might help you with a ton of use cases. But you might also want to learn the basics of Web3 and how to use these different protocols and use cases in your Solidity code. So here are some of the resources, popular ones that I've listed down. So Consensus is the biggest company that is providing developer training for Web3 certifications and other Web3 stuff. OpenZiplin has a specification of ERC20 contracts where you can easily implement your own tokens, NFTs, and other things. Questbook app is a learn to earn model where you can complete quests and earn NFTs. Figment Learn again is a website where provided by Figment, where you can learn examples of how to build the apps. And Use Web3 has a ton of content on Web3 jobs, Web3 books, and Web3 videos. And so does Web3 University and Web3 Career, where you can find jobs and write a lot of content. You can become a better Web3 developer. So I guess this is all you need to build a DApp. I know it's a lot of protocols, but you might not need all of them. But obviously, when your DApp scales, you might need a lot of indexing and a lot of resources and different protocols to make it very efficient. I think that's where all of these come into picture. And I believe there are a lot more protocols that I couldn't cover, but hopefully this helped, and you will be using them in your next DApp project. So I think that's it from my side. Thank you.